professional survey in IT in the University of Huddersfield. For those who have never been to Huddersfield, it's just 20 minutes from the Leeds and 1 hour from Manchester to the north. Okay, my paper is primarily my actually PhD's paper, I'm the co-author on that. It's really looking at how the space layout designs will affect on energy, occupants' energy behavior. Just put it into the context for this research is, I think the last year in Brisbane, in CIB W78, I presented another paper which in relation to, we can use the cloud modeling techniques to simulate occupancy movement within the building. And we can do the simulations, but the bigger question of that is we don't know why they move and how they move, what they actually attract them to move. So as follow up the research, one of my PhDs is looking into how the space layout will affect the occupant's behavior. So when you look at in terms of energy consumptions, these are sort of the key sort of factors. And climate, our previous presenter already mentioned that. Thermophysical properties, these are related to material science. And then the technical detail dimensions and the technical workmanships and HVAC system qualities. And I think the behavior of occupants is probably less well known in terms of research area, but it's become a very active area in energy research. Because I think the other 4 areas is rather established compared to occupants' energy behavior. It's because more is in soft area, more in management, more social science. So our focus in my team's primary focus is on the occupants' behavior. So as part of the research, when we look at it, there's quite a lot of literature in that area. We all know there's a core performance gap between the predicted energy consumption with actual energy consumption. There's a massive gap between them. There's quotes on 300%, 300% difference, 100% is various different types of buildings. And there's a sufficient amount of evidence to suggest occupant behavior play a quite significant part. And so, as part of the research, we did quite extensive literature reviews in this area in terms of what are the key factors or parameters will affect occupant behavior in terms of energy consumption. So here's quite a list of, we went through all different literatures, and I think we went through over 1,000 literatures and then condensed to a couple hundreds. And so there's quite a large list of parameters. And as a result of that, we published a paper which in the Renewable and Sustainable Energy Reviews to look at what are the key gaps and what are the key findings from that. The from that is really, we picked one of the key gaps in terms of research is looking at the space layout and how space layout actually affects energy behavior, people's behavior in that space, which in turn affects energy. So when we talk about people energy behavior, then you can talk typically from literature, you can look at the 2 types of key behavior, what is called passive energy behavior. There's active ones, and the passive ones is really just by being here. So your body heats, and the metabolic heat actually affects the environment. And typical Zoom like this, we have people, the typical, you have scheduled data as how many people were potentially occupying these rooms at a certain time. Then the active behavior is what you do here, you start using your computers, you turn on your HVAC systems, you open the windows, open the doors, and you interact with the building building equipment. And here is quite a few of them, use of water. There's a few of them which is still with very limited research. For example, use of hot water, which usually consume large amount of energy, but it's very limited research in that area. So when we look at these 2 areas, and when we find that the space layout is actually combined both of them. So how you design your space, how you position your furniture, actually can affect how people use different appliances, and also can affect people how move around within the space. So I have to say that at this point, for that particular paper, we only present some very early initial ideas. Research since then moved on slightly a bit as well. So when you see some of the diagram here, it's only kind of initial research concepts when we actually write that particular paper. So space layouts. So really, what we try to see here is how the space layout designs in terms of the circulations, in terms of the destinations, in terms of the position of different lines, will affect overall occupancies. And occupancy, as we know in the energy analysis tool, is one of the key input data for energy analysis tool. So when you look at the space layout designs, and there's actually interior space layout design principles, but primarily there's an idea concept called the sustainable interior designs. But I think the focus in that particular concept is focused on how to use more renewable, sustainable materials when you do designs. So it's very limited research in terms where you consider how the building is being used. Operational level maintenance is not really considered in sustainable interior design. So the idea was to design for sustainable behavior was kind of introduced when we look at this research. So it's not just about material. So if we can design certain ways to affect people how they behave in the environment, then potentially we can reduce the energy consumption. So that's really is the rationale behind for this particular piece of research. So what we got here is when you have a space layout, primarily you have circulations, people move around in the buildings, there's certain requirements, constraints you have to define in the building environment, in space, and both fire requirements and other requirements you need to consider. Then you also have different activities within that space, and you will define the function of that space. And so when it all come together, then how these things will affect, become a parameter to impact on individual occupants. And in terms of why they go down there, and because we design that way, they actually redirect into people in that particular space. And typical, we did as part of research, because I said the research is carried out a little bit, is because we did observations in quite a few buildings, especially in the universities. We have a large, what's called a student central, which is really student social areas, and the typical area in front of the doors, the main doors, which we call the eye point, which is student asking questions and about anything really. And then realize the door is always open. Because the door is originally designed always open because the particular function there is constantly the people there, trigger the doors open because it's automatic. So that's actually these things actually is because the function of the space and trigger certain areas which is not actually with original design intention. So we want to look at all these things all together, and ideally, in the end of the research, we hope we can build what we call the analytical frameworks to determine what kind of action occupants' behavior potentially they will perform under certain type of designs. And so typical where the destination is, where the circulation is, and also where the potential device will be used by the occupants. And they were linked to the early, I mentioned earlier, is the prior modeling analysis simulation techniques we use, primarily underneath the agent-based techniques we can attach to these behaviors with individual agents, then potentially we can simulate that environment if you understand how the potential space is going to be used, how the space layouts will be designed, then you can actually simulate, put into environment, then you can let the user actually move around in that space, and then you can calculate the potential occupancy data from that. So that's really is the idea behind. So here's very simple illustrations about how the space you want to look into. You have circulation, the red dot, the green lines, then you have different destinations where we're going, and some of the energy hotspot. But this is a very simplistic diagrams, really, to show how the thinking behind. And as I said, our research is to move on a little bit now, and the diagrams become much more complicated compared to what's when we write this particular paper. So really, I think that's pretty much the way forward. Is really we're looking to do a number of case studies in both different places. One in university, one in things like the galleries, and there's another one in the museum, because at the moment we are more interested in the public space, and where the movements, when actually people primarily have no control the environment, so they will primarily be passive occupants, and also their control into the building devices is very limited, so they might not be able to open the door, windows, things like that. So we're doing the observations at this point to actually look at a certain time slot and where they are, why they go there, and taking counts and people from position A to position B, how they move around. So there's 2 case studies is being done at this point, and hopefully the next times we can present more present the results, and especially we'll be able to link with our simulation tools together to present, actually link with the understanding of the space layout together with the movement simulations in order to generate all of this data. Okay, that's pretty much me.
Thank you very much, John.